Okay. Hello, everybody. Good evening. So, can you hear me? If you can hear me, you can respond. Can you hear me? And can you see the board clearly? Okay, great. Yeah. So, last week we did what? You have two parallel lines. In between, you have parallelograms. So we learned, if they are parallel and if they have the same base, the area of these parallelograms are going to be equal. That means basically the area of the parallelograms having same base and between the same couple of pair of parallel lines are going to be equal. So do you have any question from those exercises that I asked you to do? If you have any questions, if you want me to discuss any part, you can tell me now. Okay. So next one is, the next part is our second part, right? The area of parallelogram and triangles with same base and between same pair of parallel lines. So area of parallelograms and triangles with same base and between same pair of parallel lines. So if you got the concept of the area of parallelograms with the same base, then this is like the same thing, nothing complex. So basically, you have two parallelograms. Sorry, two parallel lines, right? So these two parallel, you got two parallel lines. So in these parallel lines, I will mark some base. Let it be like AB. Okay. So in this AB, I'm going to draw a parallelogram. So let the parallelogram be something like this, right? So I'm drawing this is a parallelogram. So this is going to be something like this. Okay. Then between the same two parallel lines, I'm going to draw a triangle, any triangle, right? It can be like, there's infinite number of triangles, right? It can be something like this, or it can be something like this, or it can be something like this, or whatever, right? So let me draw any arbitrary triangle. So it will be something like this. Okay, same base, same base. Okay, so let me write this A, B, C, and D. A, B, C, D is the parallelogram, and I will write this point as AB, let it be like X. Okay, so the triangle is ABX, and the parallelogram is ABCD. So what can you tell? Suppose the distance between the parallel lines, the distance between the two parallel lines, I will write it, let it be something like H. Okay, H is the distance between the two parallel lines, that is the perpendicular height, right? So perpendicular height of the parallelogram. Okay, whatever, that's it. So area of parallelogram ABCD, parallelogram ABCD is going to be what? You know, area of parallelogram is given by base into perpendicular height. Base is, what is the base? I will take this as the base. So that is going to be AB multiplied by perpendicular height. That means the perpendicular height means like when you make 90 degrees with this, what is the distance between, right? Distance between the two sides. So this should be 90 degrees. So that perpendicular height is obviously going to be H, right? Distance from here to here is the distance from here to here. So they are parallel lines, so the distance is not going to change. So it is going like in parallel, right? So if this distance is h, I mean if this is h, this is also going to be h. So area of the parallelogram ABCD is AB times h. Then area of triangle ABX. The area of triangle ABX. Again, you know, area of a triangle is half into base into perpendicular height. This is base into perpendicular height, but triangle is half into base into perpendicular height. So that will be half into base. So I can take anything as a base, right? This is a base, or this one is a base, or this one as a base. So which base I should select? So when talking about perpendicular height, I know if we have three perpendicular heights, right? So one height is from here to here, or we have other height is from here to here, but we don't know both these lengths. We don't know this one, we don't know this one. So I cannot take both those lengths, right? Those perpendicular heights I have to remove from the picture because I don't know them. But this perpendicular height, I know it, right? I mean, when you draw 90 degrees, so distance from here to here is the same distance as, I mean, h, right? The distance between the two parallel lines. So in that case, if this is h, this is also going to be h, right? So in that case, I will have to select this base. I cannot select this base because I don't know this perpendicular height. I cannot select this base because I don't know this perpendicular height. But I can select this base because I know this perpendicular height. So I will select AB base. So why I selected AB base, you know that, because I know the perpendicular height, the perpendicular to the other vertex from that base, multiplied by the perpendicular height. Perpendicular height from that base is h. Okay. So now you can see the relationship, right? So here you can see the parallelogram is AB into h. So AB into h. And here, the area of the triangle is half into AB into h. So it's AB into h is same, right? AB into h, and this is half into AB into h. So that means, right? That means if a triangle and a parallelogram have the same base and they are between the same pair of parallel lines, in that case, the area of the triangle is going to be exactly half of the area of the parallelogram. So in other words, you can write from this two, you can say area of triangle ABX is equal to half of the area of parallelogram ABCD. So this is the theory, basic, right? Very obvious, nothing to learn even. I mean, like direct, right? Very direct forward. So you can see that. So basically, if you see a parallelogram and a triangle in between the same pair of parallel lines and they are having the same base, this is very important, they should have the same base. So if they are having the same base and between the same pair of parallel lines, then you can say area of the triangle is half of the area of the parallelogram. Yeah, so let's write the topic and write it down. If any questions, you can ask. Okay. So you can write the theorem. What is the theorem? If a triangle and a parallelogram, if a triangle and a parallelogram is having the same base and are between the same pair of parallel lines, then what? Then the area of the triangle is exactly half the area of the parallelogram. Yeah. So if a triangle and a parallelogram is having the same base, very important, same base, and are between the same pair of parallel lines. Between the same pair of parallel lines. So if these two conditions are met, you can say the area, this relationship, you can say the area of the triangle is half the area of the parallelogram. That's it. Okay, this theorem is also in your book. You can write it down. So let's do a question. So let's say you have two parallel lines, and there is a parallelogram drawn. Okay, so the parallelogram is A, B, C, D, and there is a triangle. There is a triangle. And let this be, let's say this is A, B, C, D, E, and let this be F. Okay, so the question, if the area of A, B, C, D is equal to 80 centimeters squared, and AE is equal to 8 centimeters, find BF. Find BF. Let's do this. Once you are done, you can send me the answer. Okay, we got one answer. Okay, two answers. Any other answers? Okay, let's see. So what can you say? So area of ABCD is 80. Area of ABCD is 80. Then you can say what? Area of ABE, area of ABE is equal to what? Half the area of, half times the area of A, B, C, D. Half the area of A, B, C, D. So when you write this, you better if you can write the reason. You have to write the reason. At least you can say they are having the same base. You can just simply write same base and between same pair of parallel lines. Right? Don't need to write like sentences. Don't need to write essays. Just write same base between same pair of parallel lines. Right? Better to write. So same base and between same pair of parallel lines, write the same, so write the reason. In that case, you can write it is equal to half times area of ABCD. Area of ABCD is given, which is 80 centimeters square. Half into ABCD. So area of ABE triangle is what? 40 centimeters square. 40 centimeters square. But they are not asking for the area of ABE, but they are asking this length, right? So this ABF, they are asking for BF. So what else they have given? They have given AE is equal to 8 centimeter. AE is equal to 8. So we know this length and we know the perpendicular height from that base, and also we know the area. So you can write area of triangle ABE is equal to 40, right? Is equal to 40. So that means area of triangle ABE means half into base. Base is AE. AE is 8. 8 multiplied by perpendicular height. Perpendicular height is what? FB or BF. BF is equal to 40, right? So here you have 1, here you have 4. So 4 times BF is equal to 40. So you can take the 4 to here, you can bring the 4 to here, that means divide both sides by 4. Then what do you get? BF is equal to 40 divided by 4, which is equal to 10 centimeters. Okay, write it down. And then let's go to exercise 8.3, question number 1. Exercise 8.3, question number 1. Write this down and then exercise 8.3. Question number 1. Send me the answers. And if anyone doesn't understand or want more explanation on this, you can tell me. Do it yourself. Okay, exercise 8.3, page number 99. Okay, we got 1.25, 11.25. Oh, okay, no problem. 1.25. Other students, are you done? Okay. Yeah. So the area of parallelogram ABCD in figure is 50 centimeters square. The area of ABCD. So ABCD parallelogram, the area is 50 centimeters square. What is the area of the triangle PDC? What is the area of the triangle PDC? Simple, right? So you know area of triangle, first part. So you know, first part, area of triangle PDC. So they are having the same base, DC, and between same pair of parallel lines. So in that case, the area of the parallelogram, half of the area of the parallelogram is going to be as this triangle. So you can write area of PDC is equal to what? Half times what? 50. Half times 50. So that is going to be 25 centimeters square. Easy. Second one. Okay. What is the area of triangle DCQ? DCQ. DCQ. So again, this DCQ triangle also having the same base as the parallelogram and is between the same pair of parallel lines, right? Is between the same pair of parallel lines. So you can say area of what? DCQ is equal to half into again what? The area of the parallelogram 50. Half into 50 is equal to again 25 centimeters square. So basically this is the second part. This is the last part of the lesson. I mean after this one there is another part, right? So that part basically tells you if they are having the same base and between two triangles are in between same parallel lines and having the same base, then their areas are going to be same. So here look, this triangle and this triangle, they are having the same base DC and between the same pair of parallel lines. So their areas are equal, 25, 25. So basically this is the last part. So look how easy, once you're done with the first part, the rest of the parts are nothing, right? Okay, let's go to question number 2. Question number 2. Everyone, please try the questions. Don't just write down like art. Everyone should do the questions by yourself. You can send me the answers once done. Hurry up. Quickly do it. And if you're done, you can send me. So what do we have here? the point P lies on the side BC of the parallelogram ABCD. So we have a parallelogram ABCD. We have a parallelogram ABCD, and point P lies on the parallelogram ABCD. So there is a point P on the parallelogram, some point P on the parallelogram. Then what do they say? The straight line drawn through B parallel to AP. The straight line drawn through B parallel to AP means DC produced at Q. So we have a line AP, right? So we have a line AP. Okay, so let this be AP. So, and let me make it a little bit. Okay, something like this. Okay, so we have AP. And then, what do they say? The line drawn, the straight line drawn through B parallel to AP. So they are going to draw a line parallel to AP, right? Through B. So here it is B. So through B, they are going to draw a parallel line, parallel line to AP. So that will be parallel to this one, right? So it will be something like this. Then meet DC produced at Q. So this is DC. They are going to produce DC and they meet at Q. They meet at Q. And then what do they say? Further, AP produced and BC produced meet at R. So AP produced and BC produced meet at R. Meet at R. Prove that the area of the triangle ADR, the area of the triangle ADR is equal to the area of the triangle BQR. Area of the triangle ADR is equal to area of the triangle BQR. BQR. So we have to prove that. So area of this one is equal. So what are the parallel lines we have? So we know this is a parallelogram, right? So this is a parallelogram. So this one is parallel to this one, and this triangle is parallel to this triangle. Sorry, this line. And here we have another pair of parallel lines. This is parallel to this, right? Okay. So now we need to show that. If you are done, you can say yes. You can send me on chat yes if you are done. So we need to show that, prove that the area of the triangle ADR is equal to area of the triangle BQR. BQR. So ADR is this triangle and BQR is this triangle. Okay, one student saying yes. Any other students? Okay, so how to do that? How to do that? So let's see, since there are parallel lines, so let's first look at the same base. So what do we have? Like if you take this as a base, what do we have? So we have one parallelogram over here, we have another parallelogram, right? So same base between same pair of parallel lines. So from the first part of the lesson, we know the area of this parallelogram is equal to the area of this parallelogram. Okay, so just like whenever you are doing geometry questions, just try to figure out. I mean, look at the picture and picture it. I mean, what you can do, just have it in your head, put it to your head. Then you can start writing. Okay. So my first observation was here there is a base, same base between same parallel lines. So I can take this one and this one, the areas are same. Okay. So I have it in my brain now. Then what else? So is there any base here? With this base, I don't have anything, right? With this base, nothing. So here, if you take this side, you can see here I have a base. So from this base, there is a triangle going here. And it is between these two parallel lines, right? There's a base, there's a triangle going from here and between same parallel lines, right? Same parallel lines. And there is also a parallelogram going from that base and also between the same pair of parallel lines. So according to the theory, I know the area of this triangle is half the area of this parallelogram. So that is another observation. So is there any other? So here also, I can see we have a base here. So from this base, there is a triangle going and they are between these two parallel lines. And then also there is a parallelogram going from that base, from this base. There's a parallelogram and there is a triangle and between the same pair of parallel lines. Okay, so that observation helps me. Okay, so now let's see ADR, that means this triangle is equal to this triangle. How to show that? Okay, so let's first take about ADR. So area of ADR triangle. Area of ADR triangle means this. What can I do? The only thing I can do is like there's the same base and same parallelogram going. So I can say is equal to half the area of ABCD parallelogram. Okay, it's clear, right? And then what else? I will leave it like that. And now let me check about BQR. So area of BQR. So I have a triangle here and from the same base there is a parallelogram and between the same pair of parallel lines. So I can say from my theory it is equal to half the area of this parallelogram. What is that? ABQP. Area of ABQP. Area of ABQP. Now what can I do? I need to, what they are asking that ADR is equal to BQR. The area of ADR is equal to area of BQR. But here what did I get? Area of ADR is half times area of ABCD and area of BQR is half times ABQ. So some other parallelogram. So then I cannot say they are equal, right? What should I do? Maybe if I can prove that these two parallelograms are equal in area, I'm done, right? So if the areas of these two parallelograms are same, then obviously these two will be same, right? So let me check whether they are equal or not. So what is ABCD? ABCD is this parallelogram. Then ABQP. ABQP. Okay, no problem, right? I mean, they are coming from the same base. They are coming from the same base, AB, and between the same pair of parallel lines. So I can say what? But area of ABCQ ABCQ is equal to area of ABQP. ABQP. Then you can write, you have to write the reason. Okay, so I did not write the reason. So reasons you have to write the theory between the same base, between same parallel lines. Same base between same parallel lines. For both of them, same reason. For this one also same. Then for all the three, same reason, right? So in that case, now I know area of ABCQ, area of ABCQ, sorry, ABCD, right? Area of ABCD, yeah, area of ABCD is equal to area of ABQP. So area of ABCD is equal to, both of them are the same. Area of ABCD and area of ABQP both are same. So area of ADR is going to be half of this one. Area of DQR triangle is going to be half of this one, but they are same. In that case, they are also anyways going to be the same. So I can write therefore area of ADR is equal to area of BQR. Done. That's it. Let's go to question number 3. If anyone did not understand, tell me on chat, or you can unmute and ask any question. Hello? Did anyone speak? I did not hear you properly. Can you repeat, please? Okay, you can write it down. If any question, please ask. Let's do question number 3 now. If anyone did not understand, tell me, please. I will explain it again. So in these proving questions, it is very important to write the reason, right? I mean, each and every step. So I mean, in some questions, I mean, when you see as a question, you can see it is obvious this is equal. I mean, they are asking to show that two triangles are congruent. So you can see, why should I prove like it is obvious these two triangles are congruent, but still you have to write it like you are explaining it to someone who doesn't know that it is congruent, right? For that one only you are getting marks. So I mean, basically, if you are good at something, you should be able to explain it as simple as possible. So if you cannot explain it simply, that means you did not understand it clearly. So that is what, so if you are going to prove something, the two triangles are congruent or area, whatever it is, geometric proofs, write the steps clearly, write the reasons clearly. Think that you are explaining it to someone who doesn't know the steps. Okay. So what do we have? Write it down. I hope you wrote it down. Okay, what do we have here? Okay, we have a parallelogram. Do it quickly. If you're done, send me done. Or if there's no area, right? So it's also a proof question. So if you're done, you send me done. Okay, so we have in the figure, SQ has been drawn parallel to side AB of the parallelogram ABCD. Okay, such that it meets the side AD at S and side BC at Q. Okay, so we have a parallel line like this, parallel to these sides. So this is also parallel. And then we have the opposite other sides, S and Q. And this is parallel. These two are also parallel to each other, right? Right, done. At Q, okay. Prove that the area of the quadrilateral PQRS, there's PQRS. Okay, we have P right here. We have P and we have Q over here. Oh, sorry, R over here. So show that the area of the quadrilateral PQRS. PQRS is exactly half the area of the parallelogram ABCD. Half the area of the parallelogram ABCD. Okay, how to do? This is simple, I think. So this is simple. So you can see you have to like show that area of this full thing is half the area of this full thing. So let's break it, like break the question. So like we know what we are talking about parallelograms. So I mean, let's break the question like for up and down parts into two parts. Okay. So how can we do? Let's say area of this one SPQ. I mean, I'm going to my idea is just find this area separately and find this area separately, and then let's add and see whether they are half or not. Okay, so anyways, we have to start from somewhere, right? So let's say area of SPQ triangle. Area of SPQ triangle is going to be what? Area of ABQS, half the area of half times area of ABQS, area of ABQS. Okay, and then I cannot do anything further, so let me keep it like that, and let's find the area of the down part, the other part of the quadrilateral. So that is going to be area of what? SQP, right? It's SQR triangle. So what is going to be? It is going to be this triangle, and we have same base over here, and they are between the same parallel lines. So I think the area of this parallelogram is going to be half of it going to be that relationship is going to come here, right? So I can say SQR is going to be half area of what? SQCD. SQCD. Why? The reason you have to write, don't forget to write the reason. I'm not writing the reason to save time. So, okay, so now I have found SPQ triangles area. I have found SQR triangles area. So now, but I know that they are talking about the area of SPQR, right? SPQR. So let me write area of SPQR is equal to area of SPQ triangle plus area of SQR triangle, right? Area of this full quadrilateral is going to be area of this triangle plus area of this triangle. So in that case, SPQ triangle. So what is SPQ triangle? SPQ triangle, area of SPQ triangle means half of ABQS. Half of ABQS. So I will write half times area of ABQS, right? I mean, directly I wrote area because here I found, right? It's proved. So since I proved, I can write area of SPQ is directly equal to half the area of ABQS. Then plus half the area of SQR. SQR triangle is half the area of SQCD. So I can write half the area of SQCD, half the area of SQCD. So now let me take this half outside. Half is common, right? So let's take half outside. So if you take half outside, what do you have? Area of ABQS plus area of SQCD, area of SQCD. Area of ABQS means this part. Area of ABQS means this part, ABQS, and area of SQCD means this part. SQCD means this part. So that means the area of the full part, right? So you can write the next line. This is equal to half times area of ABQS plus ABCD means area of ABCD. So this addition you can write as in one word, area of ABCD. Okay, write it down, and if anyone did not understand, tell me. And question number 4, 5, 6, 7 for you is your homework. So question number 4, 5, 6, 7 homework. You can do it and send it to me. So you have my WhatsApp. So take a picture and send to my WhatsApp once you are done. Okay. So very important, do these questions. So these proof questions, you need more practice. If you don't understand, you can tell me on, I mean, even by chat or whatever, like you can call me, chat, or during the class, then whenever you want, you can ask me. But the most important thing is all these 4 questions, try them. And then let's move to the next part. So this is nothing, very simple. You already know what we are going to do. So O-level maths is, I mean, very easy when you compare to A-level. O-level maths is nothing. I mean, everything this you learn will be used in A-levels as just, you know what, like, you know, like here you use these numbers, right? 1, 2, 3, 4, 5, 6, what you learned in grade 1, 2, 3, 4. So when you go to A-levels, whatever you learn in O-levels is like that, the numbers, like 1, 2, 3 counting, like the alphabet. So like it's nothing. And also like the same thing is like this very, very small concepts has been broken into number of lessons. So that is why the content is more, but still, like if you take as a overall, it's very simple. Nothing much complicated. So don't be afraid of mathematics. Okay, let me erase it. So last part of the lesson. Last part is 8.4, which is areas of triangles between areas of triangles between same pair of parallel lines. Oh, I forgot, on the same base. So areas of triangles between same pair of parallel lines and on the same base. On the same base. So first we did areas of parallelograms with same base and between same pair of parallel lines. Then we did parallelogram and triangles together. So now we are looking into two triangles. So suppose we have two parallel lines like this. So we have two parallel lines like this. Okay. Then there are two things. It should have the, oh, these are not parallel, right? When I see from the camera only, I can see like it's not parallel. Okay, now like almost parallel. Okay, so there are two parallel lines. Okay, then suppose they have two what you call a same base. Let's say AB, same base. So this is the base. Then let the distance between the two parallel lines be H. Okay, then suppose you have two triangles. So let one triangle be something like this. One triangle is something like this, right? And the other triangle, let it be something like this, right? And the other triangle, let it be something like this. Okay, so what can you tell about the area? So let it be AB, and I will mark it like CDE. So you can say so first one, area of triangle ABC. Area of triangle ABC. Area of triangle ABC is equal to what? Half into base. Base is what? This is the base, right? AB. Half into AB into perpendicular height. Perpendicular height means like if you keep it on the floor, how tall it is, right? So this base, again, last week I did how to draw, how to draw the perpendicular, right? Here, like you cannot, like perpendicular on this base, I mean, there's nothing called slanted perpendicular. So perpendicular obviously is going to be like this. So you will extend, and this is going to be the perpendicular. So what is this length? It is going to be H, right? The distance between the two parallel lines is H. So my perpendicular height is going to be AB multiplied by H, half into base into perpendicular height. Area of triangle ABD, area of triangle ABD. What is it? Again, half into base is AB into perpendicular height. Perpendicular height of that triangle. So that triangle, so this triangle, right? So we have this triangle. So perpendicular height of that. So that means you are going to drop a perpendicular from there. So this distance is going to be same, right? Again, it is going to be H, right? For this triangle, it is going to be H. So then again H. Then another triangle we have, area of triangle ABE. ABE, also we can say it is equal to half into AB into what? Half into base into perpendicular height. Again, same like this. So if you drop a perpendicular and something like this. So it is going to be, again, this distance is h, right? So in that case, again, I can write it. So you can see half into AB into H, half into AB into H, half into AB into H. So which means areas are equal. So you can write triangles on the same base and between same pair of parallel lines are equal in area. Okay, write it down. So here basically, if you have two triangles and they are having the same base and between same two parallel lines, then the areas are going to be equal. Very simple. Okay. So here, since we are using, let's move to, I will write it down first. And then I want you to do miscellaneous exercise question number 1. Page number 104, page 104, miscellaneous exercise question number 1. Miscellaneous exercise question number 1. So it is find the length of dx. Find it and tell me. I want other students also to be active, right? Like sending a message sending a message is not, on the chat is not a big deal, right? Maybe to unmute, you are shy or something, but still, like once you're done, just send me a message on chat, right? It's not a big deal. So yeah, please be more interactive. Only like there are like 4 or 5 students. They are only those set of students are sending. So other students, please be active. And if you don't understand, tell me. Don't like keep quiet. So miscellaneous exercise 1, find dx. What is dx? Did not get any answer yet. Are you trying? Okay, yeah, I got few yeses, so I think I'll have to wait few minutes. Okay, miscellaneous exercise question number 1. Okay, we got one answer. Saubhagya. So what do we have? The length of a side of the square. Okay, square, very important word, square. A, B, C, D in the figure is 12 centimeters. So we have something like this. A, B, C, D, and A, B, C, D is a square. Is 12 centimeters. One side is 12 centimeters. That means this side is 12, this side is 12, this side is 12, this side is 12. So I just write one side is 12 centimeters. Right. Then point P lies on the side BC. Point P lies on the side BC. P lies on the side BC, such that BP is equal to 5 centimeters. Such that BP is equal to 5 centimeters. So if BP is equal to 5 centimeters, TC is going to be how much? 12 minus 5, right? 7 centimeters. Okay. Then find the length of DX. Find the length of DX. So we have a triangle like this, and there's a perpendicular drawn from here to here, which is 90 degrees. So you need to find the length of DX. DX. Very simple. So, you know, like in a square, the opposite sides are parallel, right? The opposite sides are parallel. So square is also a type of parallelogram. You know that, right? So square is also a parallelogram. Opposite sides are parallel to each other. So in that case, you can see here, we have same base. We have same base. That means these are two parallel lines, right? These are two parallel lines. So we have same base, a triangle, and a parallelogram. I mean, square is a parallelogram for me. So I have a parallelogram and a triangle, right? So I can find the area of the square, no problem, right? So area of the square, what is the area of square? Is equal to 12 times 12, right? I mean, area is length into breadth, so which is 12 into 12, which is 144 centimeters square, right? That is the area of the square. So the theorem we learned before, like we did exercises right now, what did we say? If there is a triangle and a parallelogram with the same base and between same pair of parallel lines, the area of the triangle is going to be half of the area of the parallelogram. Therefore, I can write area of triangle APD, area of triangle APD is equal to what? Half into area of this parallelogram ABCD, so which is half into 144, which is 72, right? 72 centimeters squared. Okay, so now we know area of the triangle APD, but they are not asking for the area, they are asking for dx. What is dx? Okay, so but they haven't mentioned the parallel lines, right? Yes, why? Like this is a square, right? In a square, the opposite sides are parallel. So you know that. So they don't have to mention it again. They have told this is a square. So square means these are parallel, obviously. So they are not telling it again. Okay, so that is the area of what you call area of APD triangle. Then we need to find dx. So dx is basically a perpendicular height of this triangle, right? So if you are going to write the area in terms of dx, we will have to find the base AP, but we don't know what is AP. So by using Pythagoras, you can find, right? By using Pythagoras, you can find what is AP. So basically, there are triplets, right? Pythagoras triplets. If you know them, you can use. If not, you can simply find this is the hypotenuse. This is 90 degrees. So this one squared plus this one squared, square root will give this one, right? So if you want to find AP squared or AP is equal to square root of 12 squared plus 5 squared, which will give you 169 square root, which is equal to 13 centimeters. So AP is 13 centimeters. Therefore, you can write area of APD, you can write what? Area of APD triangle is equal to 72 centimeters squared, or 72, let me just write 72, is equal to what? Half into base, that is AP, half into AP into perpendicular height, which is dx. So you know 72 is equal to half into AP, you already found, which is 13 into dx. So you can write, you can take this to the other side and you can write dx is equal to 72 into 2 divided by 13. 72 into 2 divided by 13. So that is going to be 144 divided by 13. If you want, you can convert it into decimals. That is going to be 11 point something, right? 11.03, I think. Yeah, let's do miscellaneous exercise question number 2. Question number 2. And if anyone did not understand, tell me, I will explain it to you again. Yeah. So you should learn. So what is the thing you can learn from this question? So these miscellaneous exercises are very important because these types of questions only you will get in your exam. I mean, because like 8.1, 8.2, 8.3, these questions are specific to that lesson, right? But miscellaneous exercise means mixed, everything mixed. So these types of questions only you will get to the exam. I mean, they will not tell you will get question from this part of this lesson, right? They will just mix like 2-3 lessons and they will give some question. So that's why miscellaneous exercises are very important.
in the school, or most of the teachers skip these miscellaneous exercises, but they are very important to practice. Question number 2. So it is a proof question. So once you're done, you can send me the word done. I will give you 4 minutes is enough, I think. I'll give you 4 minutes. Oh, okay. One student already did it. So you can try, the student who did it, you can try the third question. Shagin J. Okay, so what do we have? Let's sketch the diagram. So if you're trying, you can keep on trying. So X is a point on the side BC of the parallelogram ABCD. So we have a parallelogram ABCD. ABCD. We have parallelogram ABCD. Then X is a point on the side BC of the parallelogram ABC. So here we have a point X. Okay. Then the side AB produced and BX produced meet at P. So we produce this and this we produce. They meet at where? They meet at P. And the side DC produced and AX produced, and the side DC produced and AX produced meet at Q. Prove that the area of the triangle, then let's join them. So prove that the area of the triangle PXQ, the area of the triangle PXQ, the area of this triangle is exactly half the area of the parallelogram ABCD. Half the area of the parallelogram ABCD. How to do that? Okay, we got 2 yeses, 2 dones. Okay, so one thing we know is, what do we know? This is parallel to this, and this is parallel to this, but we don't know anything else. Okay, let's discuss. So how to approach? So we have to show that this triangle is half of this one. So what can we do? We know here we have a parallelogram and same base between same parallel lines. So maybe I can use it, but still, like, I don't know whether these 2 triangles, anything about these 2 triangles, right? Okay, then what can I do? One thing I know is the area of AXD is half of ABCD because of my theory. That thing I know, right? Same base between same 2 parallel lines. But about this triangle, what can I do? I mean, there are no parallel lines as of, I mean, there's no parallel line to this one. So there's no parallel line to this one. There's no parallel line or anything that I can use. So I think there's no parallel line here, right? Then what can I do? Let's take another triangle relating this side, this triangle. Let's check whether there's any other triangle. So I don't know, like, let's try to do something like this. You can see this PQ, this thing, right? And here you have another triangle, right? So you can see they are having the same base and between same parallel lines, and they include this part also. So maybe because of that, I don't know whether I will get the answer or not, but let's take and check. So one thing I know is what? AQD or ADQ, area of ADQ is equal to what? Area of ADQ is equal to area of DPQ, right? Area of DPQ. Area of ADQ is equal to area of DPQ. Okay. Then from ADQ, what can I do? So what is this? ADQ means A with ADQ, this triangle, right? So from this triangle, or from this triangle, if I remove so from this triangle, so we have ADQ, right? ADQ. So from this triangle, if I let's try to remove AXD, right? So if I remove from AXD, what happened? From this triangle, if I remove AXD, from this triangle, if I remove AXD, what is remaining? DXQ, right? DXQ. And I add this part, right? So this ADQ I can write how? This ADQ is equal to what? ADQ triangle, I can write in other words. Sorry, PXQ. So this PXQ I can write PXQ triangle is equal to what? PXQ triangle. This triangle, can I write in terms of ADQ? So what should I do? I will from ADQ triangle, so here also you can see here we have another two equal lines, right? So here also I can write area of what? Area of APD, area of APD is equal to area of APQ, right? Area of APQ. Okay. So that is two things I derived from the figure, right? From by using the theory that I learned. Okay. So how it becomes equal? There is only common base. Look, here you can see. Here you can see there is a parallel line, right? These two are parallel. And this triangle is having same base and between same parallel line, right? So this triangle and this triangle are having the same base and between same parallel lines. So that is why they are equal. So here also same. Here we have AB, AP is common. So AP is common. So therefore we have this triangle is between these two parallel lines, and this triangle is also between these two parallel lines. So that is why I told they're equal. So from this one, look at this. So from this one, if I remove this part, what do I get? From this triangle, if I remove this part, I get AXD triangle. And from this triangle, if I remove the same part, I get PXQ triangle, right? So let me write it. So here from both sides, look at this. So I have area of APD is equal to area of APQ, right? Area of APQ. So this is the same thing I wrote. So from both sides, I'm subtracting area of APX, area of APX, subtracting area of APX. Okay. So why did I do like that? Why did I do like that? Because look, area of APD is this full triangle, right? So area of APD is this full triangle. So from that full triangle, I am subtracting APX. So I'm subtracting this APX, right? So what is remaining? AXD, right? AXD. So I can write this is, what is this? This is going to be area of AXD triangle is equal to area of APQ triangle. So what is area of APQ triangle? So let me erase this. What is area of APQ triangle means? Area of APQ means APQ. So this triangle, right? So from that triangle, I am subtracting the area of APX. That means APX. This part I am removing. This part I am removing. So when I remove that part, what is remaining? PXQ equal to area of PXQ triangle. Area of PXQ triangle. Area of PXQ triangle. So now I know, look at here, area of AXD triangle. Area of AXD triangle is equal to the area of PXQ triangle. Okay, so I think we don't need this one, right? I mean, this thing is not required. So we can remove that thing. We will use only this triangle, right? Then area of AXD. So from the theorem, you know, area of AXD triangle is equal to what? Area of AXD triangle means this one, same base between same pair of parallel lines. So you can say area of AXD is half the area of what? ABCD parallelogram. So here you can substitute this here and say area of PXQ. Therefore, area of PXQ is equal to half the area of ABCD parallelogram. Done, right? So what did we do? So first, I just checked like what are the possible triangles that I can take. So here, by using this one, I was able to get one thing, okay? Or else I could have taken the top two triangles. So all these triangles are equal in area because they have the same base and between the same pair of parallel lines. So from that theorem, I wrote it here. So you should write the reason, okay? So here you can write, since they are on the same base and between same parallel lines, I can say this, right? Then I just checked these two triangles and I observed that when I remove this part from this bigger triangle, I was able to get this, right? Which is exactly, on my brain, I found that it is exactly half the area of the parallelogram. So what I did was, I subtracted the area of APX from both sides, area of APX. So in that case, area of APD, I subtracted this part. When I subtract this part, what remained was AXD. And from the other side, area of APQ, I subtracted this part. What remained was this. So by using that one, I was able to prove that the area of this is equal to area of this. Then what I did was, I found the area of this triangle. First I did was, area of this was equal to area of this. That is what I proved up to here. Then after that, my step was just using the theorem. I just said area of this triangle is half the area of parallelogram ABCD. So if this is half the area of parallelogram, obviously this one is also going to be half the area of the parallelogram. Why? Because their areas are the same. So then it's done. Okay. Using the axiom, easily derive it or not. What axiom, Shagin say? I mean, is there any other method? If it is correct, no problem. We can subtract dxq also, right? Instead of subtracting axp. Dxq. In that case, you will have, I mean, if you want to subtract dxq, I mean, the triangle is this triangle, right? We are we consider this triangle. So if you want to subtract dxq, you will have to use, can you remember, like in blue color, I wrote another pair of triangles at the beginning, right? If you use that pair of triangles, then you will have to use dxq. It depends on what two triangles you are starting with. If you start with these two triangles, you have to use this one. I mean, why? Because when you remove it, you get this. When you remove this, you get this. If you use these two triangles to start with, then you will have to remove this one. And also, wherever you use the parallel line and same base theorem, write the reason. Very important, write the theorem. I'm telling you again and again. In the board, since there's not enough space, I'm not writing it, but you have to write it again and again. Okay, then you can move to question number 3. Question number 3. Look here. So here we use two theorems we learned. The first one was this triangle. So area of the triangles between the same pair of parallel lines and same base are equal in area. So that is the first theorem we use. Then here we used our second theorem from this lesson, which is the related to parallelogram and triangle. So two places we use what we learned. So question number 3. Write it down and try question number 3. And if you're done, you can do. Okay, so we got one answer from Shagin J. Let's see. If you're done, you can do the next question, question number 4. And students who are done, you can send me there's answer, right? Find the ratio. Yeah, send me the answer. Don't know where A exactly lies. So where can we put that? Wherever you want. On the line SR. That is the only condition. So on SR, you can put it anywhere you want. Okay, let's do that. Okay, so what do we have? The diagonals of the parallelogram PQRS. So question number 3. So we have a parallelogram PQRS, right? PQRS. The diagonals of the parallelogram PQRS intersect at O. PQRS intersect at O, right? Okay. Then the point A lies on the side SR. The point A lies on the side SR. Find the ratio of the area of the triangle POQ and to that of the area of the triangle PAQ. This is A, right? So PAQ. So we have to find the ratio of the triangles, right? So how to do that? So to find the areas, maybe what can we do? What can we do? So if you're done, you can send me down. Oh, it's not done. You can send me the answer. One student sent already. Okay, we have one answer, two answers. Okay. All right. So what we can do? So you can drop a perpendicular, right? From here to here, right? So basically, these two triangles are congruent, right? I mean, these two triangles are congruent. So their areas are also going to be same. Their areas are also going to be same. And also, same way, the perpendicular heights are also going to be same. So that means if the perpendicular height from here to here is x, the perpendicular height from here to here is also going to be x, right? So that means the full length of this is going to be 2x, right? I mean, from here to here it is x, and from here to here it is x. Then the distance from here to here, the distance between the two parallel lines is going to be 2x, right? So in that case, you can write, but here, like to tell this, you have to better if you can say these two triangles are congruent first, okay? So in that case, what can you say? Area of what? PQO. PQO is equal to what? Half into PQ, base is PQ, into perpendicular height, which is x. That is the area of PQO triangle. Then area of POQ triangle. Area of POQ triangle. So area of POQ triangle is going to be what? Half into base. Base is again PQ into full length, is 2x, right? Perpendicular height is 2x. So now you can find the area, the ratio between. So you can write the first one is to second one. So area of PQO is to area of POQ. Sorry, POQ, right? Sorry, PAQ. PAQ. Area of PAQ is equal to what? Half into PQ into X is to half into PQ into 2x, right? So then similar terms you can remove. Half and half will cancel off. Q and Q will cancel off. X and X will cancel off. So you will get 1 is to 2. Now let's move to question number 4. If you're done, you can send me done. Okay, great. Okay, let's first draw the diagram. So I think I can erase this, right? I hope you wrote it down. So what is there? Question number 4. ABCD and ABEF are two parallelograms unequal in area. Drawn on either side of AB. So we have a line AB and they are drawn on either side, right? I mean, either side. So the two triangles, there are two parallelograms like this. So there are two parallelograms like A, B, C, D, A, B, C, D, and A, B, E, F. A, B, E, F. Okay, let's draw something like this. A, B, E, F. A, B, E, F. So this is parallel to this, right? Because it is a parallelogram, and this is parallel to this. And this side is parallel to this side, and this side is parallel to this side. Done. Okay. So this is the diagram. So now you have to show first one. Prove that DCEF is a parallelogram. DCEF. So let me draw something like this. DCEF. So we have to show that DCEF is a parallelogram. Noha, how did you prove that triangle PQA is equal to half of the triangle POQ? The angle PAQ is half the area of POQ. Yeah, no, like here, like we proved the area only, so we were not talking about the angles. So since that we had two triangles, so those two triangles, like we use x and x, right? So like when we have something like this, so we had something like this and something like this. So basically, this length is equal to this one is equal to this, and the diagonals are bisected, and this one is equal to this. So basically, these two triangles are congruent. So that is why this perpendicular height is also going to be, this is going to be x and x. That's why I took like that. Okay, so in this one, how to do? DCEF is a parallelogram. DCEF is a parallelogram. So you can say DC and AB are equal, right? You can say in parallelogram ABCD, in parallelogram ABCD, AB is equal to DC. AB is equal to DC. Why? Opposite sides of a parallelogram. Opposite sides of parallelogram. Opposite sides of a parallelogram. Then from this parallelogram, you can say, but in ABEF, ABEF, you can say AB is equal to FE. AB is equal to FE. AB is equal to FE. Same reason. So then you can say because AB is equal to sorry, did I write? Yeah, AB is equal to DC. So this one is equal to this one, and from this parallelogram you wrote this one is equal to this one. So obviously DC is equal to FE, right? Therefore, you can write DC is equal to FE, right? So DC equal to FE. You also know that DC is parallel to FE. Also, DC is parallel to FE. DC is parallel to FE. So, under properties of parallelogram, you learned in a quadrilateral, if the opposite sides are equal in length and they are parallel to each other, then it is a parallelogram only. So then you can write, because of these two, therefore DCEF, right? DCEF is a parallelogram. DCEF is a parallelogram. Done. So first part is done. Now try the second part. Second part. So since now I have proved that this is a parallelogram, let me slightly change the diagram. I mean, no need, but still, like for you, it's easy for me to explain if it is changed. So this is going to be something like this, right? So this side is parallel to this side because it is a parallelogram. We already proved. So second part, are you done? If you're done, you can send me done. First part is done. How to do the second part? Yep, one student already done. It's easy, right? Obvious, I think. So what should we do? Let me just like extend this one. So let me just simply extend this line. So when you extend this line, and this line also, if you want, you can extend. So now you can easily see, right? So here we have two parallel lines. So let me mark it like this point. Let it be X and let this be Y. So what can you say? You have to prove that area of this parallelogram plus the area of this parallelogram is equal to area of this parallelogram, this big parallelogram. How to show that? It's like you can say area of which one? I will again break this into two parts. I will break this big parallelogram into two parts, right? So area of what? FEXY. FEXY. Area of FEXY is equal to what? Area of this one, right? ABEF. Area of ABEF. Area of ABEF. Okay. Then this part, okay, done. I already know what this part is, right? Then now let's go to the top part. So that is DCYX. So you can write area of DCYX. Area of DCYX. What it is equal to? Again, same base between same parallel lines. So area of DCYX is equal to area of this parallelogram. So again, you are using your theorem. You can write A is equal to area of DCBA, right? DCBA. So now you can add these two, right? I'm going to add them 1 plus 2. I'm going to add these two 1 plus 2. Then what happens if I add those two? Area of FEXY, area of FEXY, sorry, AVYX, okay, it should be YX. YX, FEYX plus area of DCYX. Area of DCYX is going to be this full thing, right? So I think I am approaching. So let's write area of what? FE, area of FEYX plus area of DCYX is equal to, I just add this two. That will be equal to area of ABEF plus area of DCBA. So area of this thing plus this thing, you can see area of this FEXY plus DCXY is this full thing, right? So here in both, because for this both thing, I can replace it what? I can just write area of what? DCEF is equal to what? Area of ABEF, area of the same thing, right? I'm not going to change it. Area of ABEF plus area of DCBA. So this is what we have to prove, I think, right? So ABEF is this parallelogram. Area of DCBA is this parallelogram. So their areas are same, right? So this is what we have to prove. Done. Anyone want me to explain it again? You can tell me. Any questions? And you can try question number 5 also. If you are done, you can send me the, it's a proof, right? Yeah, it's a proof. So if you're done, you can send me that. Try it. So in the exam for such type of questions, you will get just 10 or 15 minutes, right? So it should be quick. So by now you should have figured out how to do that. Okay, let's first draw the diagram and see. So what do we have? ABCD is a parallelogram. Okay, we have a parallelogram. We have a parallelogram A, B, C, D. All right. Then EF has been drawn parallel to BD. EF has been drawn parallel to BD. So BD is this line. So EF has been drawn parallel to BD. such that it intersects AB at E. It intersects AB at E. So here we have E. So let's say something like this. Say something like this. Okay. And these two lines are parallel to each other. These two lines are parallel to each other. Intersects at E. Okay. And AD at F. AD at F. This is F and this is E. So this is the diagram, right? Prove that area of triangle BEC. BEC. The area of triangle BEC is equal to area of triangle BEC. So this is BEC, right? Area of triangle BEC is equal to area of triangle DFC. DFC. So you have to show that area of these two triangles are equal. This triangle and this triangle. Okay, how to do that? So you know this side is parallel to this and this side is parallel to this, right? So how to proceed? So let me just draw something like this. Okay, so look, I just drew some line from E to D and F to B. Okay, why I just did it, like I just to check like how to find, just when I just you can just do some scratches whenever you are struggling to find the answer, right? So when I drew that line, I saw like, look, I am supposed to find like what are the two triangles BEC. We have to show that BEC, area of BEC is equal to area of DFC. Area of DFC, right? So area of BEC and area of BED are same. Okay, area of BEC and BED are same. Why? Because they are having the same base and between same pair of parallel lines, right? I mean, this triangle is between these two parallel lines, same base, and this one also same base and between two parallel lines. So that is one observation I saw. Okay, then another observation I can see, here we have two parallel lines, right? And here we have one base. This line is parallel to this line and we have one base. So this triangle is equal to this triangle, right? Let me write it down. So I can say area of FED, area of E area of FED, sorry, I got a call. So FED is equal to what? Area of FED is equal to area of FEB. Area of FEB, right? So that I will keep aside, area of FEB. Okay, then what about now I have the relationship between this and this, right? I mean, I have the relationship between this and this. So I can write EDB. So I can write area of EDB triangle. Area of EDB triangle is equal to area of this trapezium. So what we have, FEBD, area of FEBD trapezium minus FED, area of FED, area of FED. Is it clear? Is it clear what I did here? So what I did here was area of EBD, area of EBD triangle, area of EBD triangle. That means this triangle is equal to area of this trapezium, subtract the area of this part. So what is remaining? This part, right? So I hope it's clear. Similarly, you can write for the other one, other triangle. So here we are considering this, right? DFC. So we have DFC. So this triangle. So what is with that triangle? What triangle do I have to think of? So you can see this triangle FBD, and FBC, right? Having the same base. So you can write here we have FBC, and here we have another triangle. What? FED, right? Sorry, FDDF. So I can write area of which I have to show that DFC, right? So DFC, this triangle, DFC is equal to, that means this triangle, and what is the other triangle I can consider? Same base between same parallel lines, right? This parallel line, this is a parallel line, this is a parallel line. So here is one triangle, here is the other triangle. Here is one triangle, here is the other triangle. So what is the other triangle? So that is going to be this triangle, right? So in that case, I can write area of DFC is equal to area of DFB, right? DFB. So here, instead of, I will take this later. So here, since that areas are same, I will consider this here. So I can write area of DFB is equal to what? Area of DFB is equal to what? Same way I can write like this. Area of FEBD minus what? This one minus this small triangle, right? FEB. F area of FEB. Area of FEB. Is it clear? I mean, what I did here, is it clear? So you can see what I did. Here I have area of FED triangle is equal to area of FEB. So area of EDB is equal to area of this trapezium subtract the area of this small triangle, right? FED triangle. Then again I got area of this trapezium subtract area of this FEB triangle is equal to area of DFB triangle. So now I know area of DFB and the area of EDB, right? So what is my DFB? Area of DFB is this. Area of DFB is this, and area of EDB is EDB is this, right? So here you can see you already proved that area of FED and FBB are same, right? So here I have area of FEBD subtract area of FED. Here I have area of FEBD subtract area of FEB. So here you proved FED is equal to FEB. So these two are same. This one is equal to this one. These two are the same, right? So since these two are the same, this is this thing, the area of the trapezium subtract this, area of the trapezium subtract this. So you have these two areas are same. So you can say area of EDB is equal to area of DFB. Area of EDB is equal to area of DFB. That means EDB means what? This triangle. Area of EDB is this triangle. And area of DFB means this triangle, right? So EDB means this triangle. So this triangle is also equal to area with what? This triangle, right? So instead of EDB, you can write BEC. So you can write area of BEC is equal to area of DFB, area of DFB. So sorry, area of DFB means this triangle. So area of DFB means this triangle. So if that is DBF, so that is also equal to this, right? Same base between same parallel lines. So because for instead of DBF, DFB, I can write FCD. So you can write area of FCD. So that is what we have to prove, right? It was a little bit complicated, I think, but still write it down and you can try it again later. So if any problem, any questions, you can ask. Okay, so it's a little bit late now. So I think we can stop right here. You can take a screenshot. I mean, if you did not write it, you can take a screenshot. And there's the second part, you can try it alone. And also, miscellaneous exercise we have done completely. Then the other exercises 8.3 and 8.4, you can do it alone at home and send me once you're done. Okay, so I think we can wind up the session. If you did not write it, take a screenshot. If not, if you wrote it, it's okay, good and fine. Okay, then thank you very much. What is the lesson you are doing in next week? Next week we will be starting the ratios, the fractions, then share market. So this set of lessons. Okay then.